Hey guys, Mr. Melissa here. Today we're going to talk about translations. At the end of this video, you should be able to translate a figure on a coordinate plane using vectors. Okay. Last time we did an overview of the different transformations that we'll see. And a transformation is where the pre-image and image are congruent. It's called an isometry. And so today we're going to talk about translations. And I have a bad habit of saying translations and transformations the same, so I mess up. Sorry. A translation is an isometry that maps all the points of a figure the same distance in the same direction. Remember that in Unit 8, we looked at vectors, and a vector was a force with a distance and a direction, a magnitude and a direction. So magnitude or distance was the same. Okay, so therefore to describe a translation, we will use vectors, which sounds a lot more challenging than it really is. Okay, a vector is made up of components. Okay, written as, you can see these kind of arrow brackets, MN. Okay, the M represents the horizontal change, so that's left and right. The N represents the vertical change. Okay, that's up and down on a specific point. So we say vector MN, and so when we talk about vectors, we use those arrows. Maps to point XY to X plus M, so that's the new coordinate, whatever X was plus that vector M, and Y plus N. Again, the same logic. Whatever the Y coordinate was plus the N vector. Okay, and so we see that symbolically here. Okay, what that means is vector negative 3, 4 moves to x minus 3, y plus 4. That means that each x value of the image is 3 less than the pre-image. And each y value is 4 more than each of the y values of the pre-image. Okay, so let's use this rule. XY translates to x plus 7, y minus 1 to find the translation of triangle WGN. So we have W as negative 6, negative 1. 1, 2, 3, 4, 5, 6. 1. Okay. We have G as negative 1, 0. Excuse me. So that's W, that's G. N is at negative 4, negative 3. 1, 2, 3, 4, 1, 2, 3. G. Okay, so now we're going to use this rule. Since it says triangle, make sure I show these triangles. Okay, remember we can do these translations with any shape. Triangles are just nice to see. Not a whole lot of points, but you can also see the reflections and transformations happening. Okay, all right. So we have the rule, and it might be written as 7, negative 1. And so we're going to see what that looks like in our image now. So here's our pre-image. And so with W, we'll move it 7 to the right. 1, 2, 3, 4, 5, 6, 7. And then 1 down. And that will become W prime. Okay, we'll do the same thing with G. Move it to the right 7. 1, 2, 3, 4, 5, 6, 7. 1 down. G prime. And then in 1, 2, 3, 4, 5, 6, 7, move it down 1. Okay. N prime. Okay, and so now you see this triangle, W prime, G prime, N prime. And you should see that it's the same shape, same size, everything's the same except its position. Okay, and that's a translation. Alright, flipping to the back. says find the vector that describes the given translation. So here we have it. From Z to U. How do we move from Z to U? Well, we go 1, 2, 3. Am I right? 1, 2, 3 to the right, 1 up. And so I'll say 3, 1. From Y to W. Okay, so we're at Y. We're going to W, so we go over 1, 2, 3, 4. And then we go down 1, 2. So vector 4, negative 2. From U to V, we go over 1. Okay, it's always easier to get out of order when there's a big difference, but make sure you do the horizontal first. Over 1 and then down 1, 2, 3, 4, 5. From X to W, go just down 1, 2, 3, 4. So we'll have 0 for our X coordinate and then negative 4 for our Y component. Sorry, component, not coordinate, for vector. From V to Y, so then we'll go 1, 2, 3, 4, 5, 6 to the left, so it'll be negative 6. And then it doesn't go down any, so 0. Okay, and then it says a point is mapped using the vector to negative 6. The image is W. What is the pre-image? So it says that we moved right twice and down 6 to get to W. So what was the pre-image? Well, if we want to find the pre-image, then we'll just do it backwards. Instead of moving right twice, we'll move left twice. And instead of going down 6, we'll go up 6. And so when we do that, we find that our pre-image was the point Z. Okay, so not too tough there. Just counting it up. Let's go on to the next thing. Okay. So now it says find the image of the point under the translation given by each vector. And so we have this point to start off with. It is negative 4, 2. And now we're going to use these vectors to place it anew. Okay, so we're at negative 1, 4. So we'll go left 1, up 4, 1, 2, 3, 4. And that'll be this new point. This will be A. Okay, and so then that point, we should be able to use our coordinates, is at negative 5, 6. Okay, and you'll actually see that I could, instead of counting it on the coordinate plane, I really can take this point and then use the components. Negative 4 plus 5, and that'll be 1. Negative 3, 2 minus 3, which would be negative 1. And so that new point should be at 1, negative 1. Okay, and that's the same thing as if I went over 1, 2, 3, 4, 5, and then down 1, 2, 3. Okay, and I'll label these as points A, B, C, D, but understand that these are primes of this original point. Okay, all right, so 4, 2, so negative 4 plus 0, negative 4. 2 plus 2 will be 4. So my next point will be at negative 4, 4. 1, 2, 3, 4, 1, 2, 3, 4. And that's point C. And then finally, at 10, 4. And so negative 4 plus 10 gives me 6, a lot better than counting. 2 plus 4 gives me 6. And so I'll be at 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. This point here, D. So using that, the components to add rather than counting out kind of makes it a little bit easier when it's available. Okay, it says write the vector that would map the given point to the origin. Okay, so our original point, negative 4, 2, we want to map it to the origin. Well, we'd have to basically do the opposite. So how do we get to the origin? We'd have to move right 4 times, so 4 for our x component. And then we have to move down twice, so negative 2. And so this vector would have mapped it to the origin because negative 4 plus 4 is 0, and 2 minus 2 is 0. Alright, now that's translations for you. See ya.